Hello, welcome back. Today let us continue our previous topic, alkenes. So we were discussing preparatory methods of alkenes, and we have seen the reaction of dehydrohalogenation. We have seen it in a great detail for 30 minutes. So we know what is Zaitsev elimination, Hoffman elimination, what are E1, what is E2, and what is E1 CB. How do you do carbocation rearrangement and all stuff. So today, let us continue with the preparatory methods of alkenes. So from the first, we were discussing preparatory methods of alkenes. So we have discussed only one reaction of it, that is dehydrohalogenation. So let's see the next reactions. So the next one we have here is cope elimination or cope reaction. So what is cope elimination or cope reaction? So we have a 3-degree amine oxide. Okay. So we have a 3-degree amine oxide and it has a beta hydrogen. What is alpha position, what is beta position, we all know, right? So this is alpha position, this will be beta position with respect to the amine. So it has a beta hydrogen now. So this beta hydrogen, what would happen is it is going to give electron, remove as H plus. Okay, so that's what is going to happen, and then this big group is going to come out, that is called coelimination. So here there is some kind of intermediate forming mechanism is not that important. So Hoffman elimination takes place. This bulky group is eliminated, and then the hydrogen gives electrons. So you get an alkene. So this is called co-elimination. So next one we have dehydration reaction. So dehydration happens in case of alcohols. Why in alcohols we have OH and you can remove a H combined with OH. So here what would happen? So primary alcohols undergo E2 reaction and secondary and tertiary alcohols undergo E1 reaction. Means simply hydrogen gives electrons. Sorry, OH gives electron. No, sorry, hydrogen gives electrons, so it gets H plus, and then OH takes electrons and go as OH minus. So H2O is released. So removal of H2O. So here the reagent is concentrated H2SO4. Okay. So here the reagent is concentrated H2SO4 and then alkane is formed. So let's see, in primary alcohol, we know E2 reactions. So E2 reactions happen in a single step. Okay. So we have a transition state forming here. So this is the alcohol we are having, CH3, CH2OH, ethanol, and then you are treating it with concentrated H2SO4. Okay. So what would happen? First of all, right, this H plus from this acid solution is going to attack this OH. Okay, so it will get OH2 plus, right? And then a transition state is formed like this. This H2SO4 molecule, it has lost H plus, so H2SO3 minus will, sorry, H2SO4 minus will be present, and H, CH2, CH2, and OH2, which is going to come out now. So, transition state is formed, and what would happen? This is released, and then a double bond is formed like this. CH2 double bond CH2, and then H2SO4 is anyhow there in solution, and then H2O is there in solution. So this is in case of primary alcohols, it is an E2 mechanism, single step mechanism. So in E1 mechanism, the H plus comes and attacks the OH minus, right? And then OH2 plus is formed, and H2SO4 minus is there in the solution. So OH2 plus comes out, just like the previous one. And then what would happen is the H here will give the bond. Okay. So it will give the bond and then a double bond is formed. That's how an alkane is formed. Alkene is formed. So this is dehydration or removal of water. Now we have dehalogenation of vicinal or geminal halides. What is dehalogenation? Removal of HX is called dehalogenation. Sorry, removal of X2 is called dehalogenation minus X2. Okay, so vicinal or geminal dihalides. So what are geminal or vicinal dihalides? When the halide groups are present on the adjacent carbon atoms like this. So carbon, carbon, they are side by side, and then they have the halogen. So these are called geminal or vicinal. So what would happen in this reaction? E2 mechanism, single step. This one would give electrons, one would take electrons. So X and X, and here the reagent is important, Zn and heat. Okay, zinc and heat. Something reduction is going on here. So a double bond is formed like this, just like in the previous reactions, and then Zn X2 is formed. So this is called dehalogenation of vicinal or geminal dihalides. Now next one we have a very important reaction called Hoffman exhaustive methylation followed by elimination. Very big name, or it can also be called as some reaction with quaternary ammonium salt. We have written it here at the front. So it is heating of quaternary ammonium hydroxide. So you are going to heat quaternary ammonium hydroxide. Right, where were we? MA, right? Huh. So first you take amine. Okay. First you take amine and then you treat it with excess of CH3I. Now what would happen by treating it with methyl iodide? So exhaustive methylation takes place. Means in the amine, the hydrogens are replaced by the CH3 groups, the methyl groups. So a quaternary ammonium salt is formed. So this quaternary ammonium salt is again treated with AgOH. Okay. So when it is treated with AgOH, a quaternary ammonium hydroxide is formed. Again, when you heat quaternary ammonium hydroxide, alkene is formed and it would be a Hoffman product. So Hoffman product is what product? Less substituted is a major product, right? See, now, first of all, you have this. Okay, NH3 plus. You're treating with the excess of methyl iodide. Okay, and then what would happen? uh, all the hydrogens are replaced with methyl groups, and then iodine radical is present here. So not radical, iodine ion is present here. Now again you are treating with AgOH. Okay, first you treated with CH3I, now you are treating with AgOH. So what would happen on treating with AgOH? So alcohol is formed, right? Quaternary ammonium hydroxide is formed. So OH minus ion is formed here. So OH minus ion is formed here, and then when you heat it, this salt is going to come out, and once it comes out, it is going to get a charge. So a Hoffman product is formed, means less substituted will be more stable. So among these two, this position is less substituted, right? So that's why using E2 mechanism, Hoffman elimination, Hoffman product is formed. So this is HEME, or Hoffman exhaustive methylation followed by elimination, or you can also call it as heating of quaternary ammonium hydroxide. Now, we have pyrolysis. So pyrolysis you do two compounds in order to obtain alkene. So you do pyrolysis of ester or you do pyrolysis of xantharates. Both have the same mechanism and those both are same. So what is ester? Double C double bond O R, right? This is ester. C double bond O R prime. Here we have ester, right? So here this is ester functional group. Now you are heating ester. What is pyrolysis? Heating in absence of air. So you are heating this ester. So what would happen is, uh, you can see the mechanism. The ester, what would happen? The hydrogen will be given out, and then the oxygen. Uh, right. Wait a minute. So the hydrogen gives electrons, and it comes out, and then this oxygen takes its bond, and then what would happen next? This bond is taken by it. This hydrogen comes and attacks this oxygen. So simply H plus is released by giving this bond, and then oxygen retrieves this bond. This H plus goes and attacks this oxygen, right? This H plus goes and attacks this oxygen, and then what is formed? And um, carboxylic acid is formed along with an alkane is formed, right? So an alkane is formed like this. This part forms alkane, and then a hydrogen which has been released here, it goes and forms OH there. So, and carboxylic acid is also formed. So this is pyrolysis of ester, and generally it's also the same happens. Just instead of the carboxylic acid here, here you are forming this compound. Okay, so you are getting thiosulfate and methyl sulfide. Okay, the mechanism is completely same. Here you have S, double bond S and O. S means sulfur here. Okay, so the mechanism is same. You can see. Now we have Wittig reaction. So what is Wittig reaction? So in Wittig reaction, aldehyde or ketone, aldehyde or ketone, it is going to react with this compound, which is called phosphorine. PH3P means here PH3 means phenyl. Okay, so P means phosphorus. So triphenyl phosphorus, this compound is called phosphorine. It is going to react with this compound phosphorine, and then it is going to form an alkane like this. Okay, so you are going to take a carbonyl compound, just replace the double bond, this oxygen with CH2. That is nothing but Wittig reaction. So mechanism is not important, just how this works. A replacement of double bond O with CH2 is C. And then you can see this byproduct is phosphorine with double bond O. These two are exchanged. Now we have a cold electrolysis of succinate. Now, what is Cole's electrolysis? With this, the elimination reactions are done. So we are going to enter the other reaction section. Cole's electrolysis of succinate. Succinate looks something like this: C double bond O, C double bond O. Such kind of these things are called succinates. So you are going to electrolysis is going to take place. Electricity is passed to the electrolyte you are using, and then what would happen? This uh, is given out. These salts come out, and what would happen? A new bond formation takes place like this. How will they come out? In form of CO2. At anode, anions react. Okay, so at anode, the anions react and they form CO2. 2 moles of CO2 is formed, and at cathode, the anions react and then form KOH and H2. This is called the electrolysis of succinate. And then we are reached the last section of preparation of alkenes, that is controlled hydrogenation reactions, which are very very important reactions. Many questions are asked on this section. We have three reactions here using Lindlar's catalyst. We have Birch reduction, and then we have P2 catalyst, which is less important. Okay, now controlled hydrogenation. So we have seen hydrogenation reactions in previous alkene topics. So what is hydrogenation? Adsorption in with this Rani nickel. Hydrogen is like hydrogen is adsorbed, and then a transition state is formed, and then the double bond disappears and forms a single bond. Now we want to do controlled hydrogenation. Means you want alkene you have alkane. So you have to take only one bond. You don't do too much reaction such that both the pi bonds break. Okay. So controlled hydrogenation is your hydrogenizing in a controlled way. Now you can do this in three different ways using Lindlar's catalyst. So what is Lindlar's catalyst? Very important, very very important catalyst in whole organic. So it is PDBASO4 in quinoline. Okay, so that is called Lindlar's catalyst. So whenever you are going to use Lindlar's catalyst, then a cis alkane is formed. Cis alkene is formed means this hydrogen is broken, and then the hydrogens are going to attach on the same side. Okay, when they are going to attach on the same side, cis alkane is formed. Okay, so very important Lindlar's catalyst. What is Lindlar's catalyst? PDBASO4, palladium barium sulfate in presence of quinoline is called Lindlar's catalyst. So Lindlar's catalyst hydrogenation of an alkyne gives you a cis alkene. And then Birch reduction is opposite of it. A trans alkene is formed. So Birch reduction takes place in liquid ammonia, sodium or lithium. Okay. So in liquid ammonia, you can see you can directly remember it as Birch reduction. So alkane, it is going to hydrogenize, and then hydrogens are added on the opposite side. Okay, so that is why trans alkane is formed. Here anti-addition means from the opposite side. Here syn addition means from the same side. Syn addition and anti-addition are very important terms, and we are going to come across them again in later topics in properties. So we have P2 catalyst or Ni2B. Okay, it is here a cis alkene is formed. Okay, and then whenever you use Ni2B instead of here, like you're going to take alkane and then react it with Ni2B, or this is also called P2 catalyst. So an cis alkane is formed. Okay, a cis alkane is formed. Alkane is formed. And for 1, 2, and 3, means for these three, alkane is not terminal. Alkane is terminal, then this does not takes place. So alkane should be somewhere in middle of the chain. Okay, right. So that's it. We are done with all the preparatory methods of alkenes. So what are the different preparatory methods of alkenes? As usual, let's see the flow chart. Now, we have elimination reactions, we have controlled hydrogenation reactions, we have electrolysis reactions. So, what are elimination reactions? We have many elimination reactions. So, we have dehydrohalogenation. Here, use alkyl halides. So, first you take alkyl halide, react it with any base, and you are going to heat it, and alkene is formed. So, if the base you are using will be bulky, if you are using a bulky base, then Hoffman product is formed. What is Hoffman product? Less substituted is the major product, and what is Seidzev product? More substituted is the major product. Okay, so when the base is bulky because of SIP, means steric inhibition, there is a problem of formation of double bond or attack of H plus, right? So Hoffman product is formed. So reagents you are going to use is alcoholic NaOH or KOH. You have triethyl nitrite, or you are going to use ethanol as solute, and then you have NaNH2. These all are important reagents used in case of dehydrohalogenation. So we have dehydration of alcohols. So we have just seen concentrated H2SO4, H2O is removed. So when H2O is removed, a double bond is formed like this. And then we have dehalogenation of vicinal or geminal halides. So this will be happening something like this. E2 mechanism is going to take place. Okay. Now we have exhaustive methylation or HEME. So amine, you're going to treat it with trimethyl iodide, and then ammonium salt is formed, and then react it with AgOH. Hydroxide is formed, heated, and alkene is formed. That is Hoffman exhaustive methylation. Important alkene formed is Hoffman product. Now we have pyrolysis of ester. Pyrolysis means nothing but heating in absence of air. So this group is going to come out and form carboxylic acid, and the remaining is going to form a alkene. Now, co-elimination, we have seen you are going to need a beta hydrogen, and then this bulky group is removed, and then once this bulky group is removed, a Hoffman product is formed. Those all are elimination reactions, and we have seen state the product more substituted is major, Hoffman product less substituted is major. And then we have the controlled hydrogenation reactions. Lindlar's catalyst, cisalkene is formed. Birch reduction, transalkene is formed. Ni2B or what is that? P2 catalyst, cisalkene is formed. And then Cold's electrolysis, two times of CO2 is formed at anode, and at cathode C double bond C is formed. That's it. Alkenes preparation is done. And in the next video, let us see properties of alkenes. So we have plenty number of properties in alkenes, like many. Okay, so see you in the next video. Thank you. Have a great day.